All right, so today we are doing. Okay, so finally I'm gonna try to get maybe a better demo of what I want to do. Okay, I kind of like I've gone through so many iterations on this topic, and I'm like every time it gets better and better and better. I'll finally get the perfect product, I promise. No, but I mean, jokes aside, we like we've got tons of coding harnesses. We've got Grok build, we've got like Codex, we've got like I mean it's even like a mixed up right now. Like I mean you've got agentic stuff. Agentic is more of like a very broad sort of like assistant harness maybe, or like it's kind of like a bigger thing I would say than a simple harness. I think the concept of a harness really, I mean you can even ask Grok if you want, like what is an LLM harness, right? And you'll see it's probably something very it's going to give me a very specific definition, which is basically it's like the LLM is very raw, right? Like the LLM per se, like it's raw, like in a very primitive sense, the chat interface is a kind of harness, right? I mean, you're seeing here, so it's kind of like there's code around these, right? There's some piece of deterministic software that is orchestrating the model, that is basically sort of like biasing a certain type of, like baking in a certain type of behavior. The agents are being spawned, how do they talk to each other, or telling them the fact they can talk to each other. Things like these, right? I mean, what is an AI agent harness? Agent is model plus harness. Yeah, I don't know. I really don't know if that's really what it is. But it's essentially a loop, really. It's kind of a loop, right? And so the model is the brain, it reasons, plans, and generates text tokens. The harness is everything else: the body, tools, memory, workspace, control system, everything that is around this. Essentially, the harness is just the wrapper. Um, or like the model is the back end, the harness is the front end. You can go with whatever flavor of analogy you want, and you will probably not be right 100% of the time anyway. While the term is smarter, most got stronger and with similar workability, the quality of the harness often determines real world performance. That's true. It is something that is true, right? But again, let's not get into these right now. So what I'm building is, so I'm building Uncertain Systems, which is a platform. Um, it's Uncertain Systems is a human learning harness, right? I'm kind of pulling a bit from the hype of the word harness here, right? But it is really at its core the best way that I found to kind of describe what I want to do with it, or what I want to build, what I wanted to build. Learning, and by the way, I recently discovered I keep forgetting his name, because I recently discovered this guy on YouTube through actually linked through X. How do I learn with AI? I think this video went quite viral by the standards of this type of content, because it had 115K views. How I use AI to learn, and it's actually a very
How
good
could we
video.
use AI to?
It's a very good video, and he kind of goes, and I would just definitely recommend to watch it, right? So he actually describes a lot of these, right? The learner and so he describes like the way, well, the way currently things are being, like the way learning works, right? So you've got a learner, you've got like a bunch of learners learning from one outlet, one how does he say this? He's exactly, learners learning from one outlet, and then yeah, basically learners and outlets, right? So he basically like builds up towards this concept of like what are the tutors promising, and how like what learning actually is, and he talks about like how you expand basically how like in the edge of knowledge and whatnot. And he kind of like build, I don't know if this is exactly. So basically, this is like the way that learning goes, right? You probe until you kind of like don't know, and then you go back a little bit. So, it's one of these things where he built, either it's a skill. I don't remember. He mentions that in the video. Like it's either a skill or something. That he's using the Pi. I believe it's the Pi agent that he's using for these, or is I think it's using Pi agent, but I'm not too sure. Is he use Pi agent? Anyway, regardless of these, The point is building up like he builds up a framework or a bit of a harness in a way, right? So like he has his own opinionated way of how he learns with AI, and he's implementing that with the agent, right? The agent creates, I think there's like the entire like thing where the agent just creates the entire sort of set of content, creates the graph of the topics, like sort of the requirements of like what topic is a requirement for what other topic. There's a layer of verification, and then basically there's some kind of back and forth quizzing to make sure that you're not really sort of fooling yourself into pretending that or thinking that you know something, that you've learned something, right? I mean, this is a harness, right? What I'm trying to do within certain systems here, and I'll see this now, is kind of be a bit more, less CLI and more application layer, in the sense that you can do what you can do from a CLI perspective and interface. The way that I design the harness is kind of following a set of different principles, right? So the baseline of my base hypothesis with these is that how to put it, we need to take a step back, right? And we need to, the way that I like to phrase these is testing and quizzing, right? Like you have to be honest with yourself. You know what I mean? Like, and this is a good point. He brings a good point here. Like you can quiz yourself, but you can still cheat on quizzes, right? You can still cheat on quizzes. That's kind of like where I try to basically be very, very specific about that. The harness that I'm building, it kind of should be uncheatable, right? In a way that you cannot even cheat yourself even if you want to, right? This is why like the concept of proof of work is a very key concept in the uncertain systems human learning harness, which is basically the harness is forcing you to generate proof of work, right? And that's where it's a continuous building, it's a continuous iteration. I haven't got it perfect yet, but you need to find that balance between a harness that is very good in helping you achieve what you want to, but it's not too much in your face, right? And it doesn't become an actual problem and distraction, right? You do not want to be distracted by how to handle things and sort of the stuff around. The harness should almost feel invisible in a way, right? So essentially, the proof of work is what matters, because then once you have proof of work, you can go formal, right? You can embed this proof of work. You can generate an embedding space. You can kind of basically start doing cool things around like mapping and representing the proof of work mathematically, and representing that in a high dimensional space, where you can then do actual learning tracking, and that you do not have to rely on the answers of a quiz, right? Because the answer of a quiz won't always mean necessarily that you've learned that. And there's always been my critique with things like mastery learning, because you then end up optimizing for the quiz more than actually learning stuff, right? So the idea is the uncertain system forces you to actually generate proof of work. It builds a learning world model around this, and basically that's how that's how it guides the learning, right? um you're going to be working, if you want to play with these, you're going to be working with workspaces, right? So and this is one that I'm building for knowledge tomography, which is a topic that I want to learn about, right? And so you're going to be working with workspaces like these, and that's kind of like a knowledge map, right? There is kind of two layers to the framework, or two layers to the harness. One is the knowledge map in the workspace that you essentially kind of, it's an infinite map. You can grow, it can grow in either direction. It's kind of like a notebook. You can take notes. You kind of like can build, play, and explore, a bit like similar to like the different modes you find in harnesses, in coding harnesses. You have like the plan mode and things like these. Now you're in build mode, right? So this is the harness really. You're in build mode. So you're actually building what you want to, you're building what you want to learn, right? And this is a bit maybe a good contrast with respect to things like this, where the actual paths are completely outsourced to the LLM, like, which is okay, right? But like I think my point is the building of the map is a learning experience as well, right? If you're given the map, you're like, it's like boom, okay, what? Yeah, sure, these, that. Like you like, and always ask the question: is there more that I don't know? Like, is there more that I should know in this map? Could I extend this box here on the left and the right? And so that's why the way that I build these, the way that I'm building these, the harness is basically, it's got a build mode, a play mode, and an explore mode, right? So build mode is where you build stuff. So you know, we've got a few things here, like an introduction to knowledge tomography foundations. We've got a few things that are like geometrically or geographically around these, but you can move things around if you don't want to you know, put them right now here. You can yeah, essentially you can basically, you know, you can build things around, right? So for example, you can say, look, fusing boundary gaps into dimension knowledge profiles. And I'm going to get into this a bit because I'm building these here. So here we have knowledge inference. That's for later. I don't want to work on this right now. Brain activity stuff. This is region groups, foundational material, knowledge sense. This is more on the sensing side of things. So this is more for the like hardware device building. You know, and it's kind of like a, yeah, as you can see, it's like you build, you learn as you build, and as you play, and as you explore the knowledge map, right? What I don't like about this one is we've got some kind of introductory section here, right? So introduction to knowledge tomography foundations. We've got introduction, then we've got probing Latin knowledge. This is interesting and related. Calibrating elicited gaps against these some of these things I'm not too happy about. So what I also want, you know, this is like the idea here is I can get a few of these things, I can park them for now aside. I think these feel a bit too they feel a bit too stretched, like, because I did generate all that with one of the tools here that we're going to look at right now, right? But I'm just going to add a note and then basically refine later. Okay, so this is something we're going to be working on later, but you can see these actions alone are already part of the learning, right? I can also go here and explore and basically try to understand, okay, so explain what's in here, right? And so that's kind of the explore mode, where you get to ask the model behind the harness things like, you know, these regions these region centers on longitudinal and iterative methods for tracking how personal knowledge boundaries and gaps evolve across repeated elicitation sessions. It links calibration of elicited gaps against boundary drift. Okay, not bad. I can add it as a note, so I can keep this here, and that's good. I mean, essentially that leads with the effects of eliciting knowledge and how that actually at the same time changes and modifies the knowledge, right? So that's something to refine later. Let's go back to build mode. So we've got synthesizing tomographic knowledge profiles. I'm not too happy about the profile stuff here. Reconstructing knowledge models, integrating multi-angle reconstruction into dimensional profiles. So you can see I need to spend time understanding a bit, having a bit of a good feel of what it is that these things are suggesting me to explore, right? Gaps project across demographic slices. Mapping personal knowledge. Boundaries and gaps. Probing. So this is clear to me. It's about like introduction. This is about probing Latin knowledge. It's about synthesizing tomographic knowledge profiles. So we're talking about some kind of profiles, models, aligning elicited gaps. Another thing I can do if I do not understand these too much, or I'm like, I'm not so sure if that's not like a bit LLM BS at the moment, I can simulate the block. And I can get questions and I can get like sample questions, sample exercises from these topics. So I'm simulating, what learning this block would actually help me understand, right? So I'm probing a bit inside the map, and I'm understanding, trying to understand. Okay, like what am I going to learn here, right? I need to refine a few of these because I would like it auto adds them to the collection, which I don't like it, and it doesn't let me do a modifier prompt upfront. I need to fix that. That's a bug. So questions, for example, person X elicitation probe flags a gap on Bayesian model comparison, yet the multi-angle reconstruction from these three domain slices raise that region as partially filled. Person X elicitation probe flags a gap on Bayesian model, flags a gap, but partially filled. Reconciliation rule you would apply and a single checkable output. What else? You have a personal boundary map showing unknown cells in dimension D2 and a tomographic profile synthesized from 4 projection angles. This is like, no, the failure mode appears if you simply average 2. 3 topics, multi-angle profile for the same topics. Compute 1 fuse gap vector entry. So, I mean, this is overall about it's a bridge between, if I understand this well, it's a bridge between between knowledge, between the raw elicitation, right? Dual elicitation probes fusing boundary gaps. So this is about the gaps between elicitation and across dimensions. I mean, it's essentially, it's talking about the tomographic profiles of a learner. And I guess because these are multi-dimensions, and when you're how do you do the mapping? I guess that's where it's going. I mean, it's okay. I think it's kind of, it feels a little far-fetched in my opinion, and I almost feels like this cross pattern always leads to like a very good starting point. Here's about reconstructing knowledge models. Boundary maps into coherent cross-sectional reconstructions of what a person knows. So this is about knowledge models. This is about this is about boundary maps. Boundary maps, knowledge, and those things are kind of more tangent. That's why I'm like, I tend to usually just do things like these and then focus on these first. This is something that as I'm testing this is kind of a common pattern. Like I notice when you build knowledge maps like these, diagonal topics are usually a little harder to kind of like grasp initially if you don't understand the center of a region. If I go in explore mode and I select these guys, oh wait, let me just actually do these well. This region covers the foundational core of knowledge tomography, systematically mapping what a person knows, scope and core questions, and addresses techniques for detecting knowledge boundaries and gaps alongside elicitation methods. Such, oh, that's back. Okay. But it almost feels, I almost feel actually good about it. I think that's a good starting point. And then those things are more like, again, I would still park these things aside. I group them, they're related to these, but I would kind of like map them aside. And then I would basically do I would still tag them with like what it is that they do, and then go back to these and probably just play with that a bit. And again, let's go into play mode. Okay, so let's go into play mode. When you're in play mode, you can just basically go and get into any of these, right? So play mode means you pick a topic, and then basically you can either explore or drill, right? So explore is, basically what I recommend when you don't really understand um, what it is that you're going to be doing, and then you can explore with AI or solo. Okay, with AI, it's like more of a conversational approach, and solo is more like leave me alone, and I just want to focus on exercises, kind of more project type of thing. It's not like there's no AI involved in that beyond generating a set of things, that a set of activities that you can do as part of that exploration. And drilling is different. Drilling is like time session, boom boom boom, go and and hammer the thing, right? And when you do exploration, this is, you jump into our integrated learning environment, um, and basically that's how it looks like. So you start playing this block, and when you play this block, you basically get to pick how you want to approach these. Do you want to go narrow first, balanced, and broad? I kind of often like narrow more initially, because you can still expand, right? We're zooming into that block. You're zooming into this block, and essentially that gets you into, and I'm going to stop here because I only have 20 minutes, and I think I've gone a bit over already. And that gets into the ILE. The ILE is this learning environment here, where you kind of have your local map. This is like the zoomed in of like what we've just seen. So I'm just gonna skip all these, and essentially that's what you get to, right? So here's where you have the AI sort of companion, like the AI dialogue, right? It's not a tutor, is guiding you through a dialogue of topics, exercises, and questions, right? So it's not gonna like teach you necessarily the stuff. It's kind of the core of the harness. And as you can see, there's multiple stuff in here. You notice that as I speak, things get recorded in here. So that's the transcription. This is the proof of work that I was talking about, right? So you cannot copy paste anything from AI here. You're not like from another chat. You cannot like, you're bound to just like speak out loud and go through the learning journey out loud. Okay. And you can stash your thoughts if you don't want them to be evaluated. You can pick something from stash and put it back in here. You can go and take a look at your backlog of stashed thoughts and whatnot. We have a few tools here, a canvas, a notebook, but you can also just go, out, allow these, sort of little picture mode to be floating around here. And then, you can do the learning off platform, right? You can share your screen. You can do the learning completely off platform. That's no problem at all, right? The idea here is these essentially. And so, your chapter tool is where you're going to see the different exercises you can do, right? Some of these things are locked. They have dependencies. But as you can see, you can go deeper and deeper and deeper, and you have another infinite dimension of things you can explore here, right? So you can go beyond these. That's the whole point of the harness, is that it's infinite, right? So establish what knowledge tomography means, the core idea of reconstructing a fuller knowledge structure from partial, noisy, or missing views, and why that framing matters for learning gaps. It's up to you to figure this out. And whenever you're going to submit something, because I picked AI mode, is going to respond to me, and we're going to have a dialogue, and then, I'll expand on these in another session. I'll actually do a few examples coming up soon, okay? But I hope you're getting a feel of like what it is, and then you can go back to your workspace and continue, right? That's basically this session, you're back in the map, and yeah, basically infinite learning. Okay, so this is like, there's a lot to this. There's DAX, there's goals, there's simulation you can do, there's the knowledge, there's the embeddings map. It's a huge platform, but essentially the core of it is the harness, right? It's that opinionated way of forcing you to learn with this kind of like system that is shaping the path for you, right? But at its core, you have the build mode, the play mode, the explore mode. And again, what you're doing here is you're building knowledge. Okay, cool. See you guys tomorrow. I'll try to stream daily and do actual examples of these.